Try it right now. Take your finger and tickle the bottom of your own foot. Nothing happens. Maybe a weird sensation, but no laughing, no flinching, no uncontrollable squirming. Now imagine your friend doing the exact same thing. Same spot, same fingers, same motion, same pressure, same speed. You'd probably scream and kick them across the room. Same touch, same nerves, same skin, completely different reaction. That's strange enough on its own. But here's the part that really should bother you. Scientists have spent decades, and real research money, trying to figure out why. There's an entire body of neuroscience dedicated to something you assumed was just a silly kid's game. So let's actually answer it. Why can't you tickle yourself? The first mistake people make is assuming tickling is a touch problem. Like maybe your own hand isn't sensitive enough, or your nerves get used to your own skin. That's not it. Your nerve endings don't care whose finger is touching you. A touch sensor in your foot fires the same signal whether it's your hand or someone else's. So if it's not about the physical sensation, it has to be about something happening upstream, in the brain. And that's exactly where researchers went looking. Here's the concept that unlocks the whole mystery. Your brain is constantly predicting the future, not in a psychic way, in a mechanical, second-by-second way. Every single time you move, your brain doesn't just send a command to your muscles and wait to see what happens. It sends a copy of that command to another part of your brain that essentially says, "Here's what I just told the body to do. Get ready for the result." This is called an efference copy, and it happens constantly for almost everything you do. It's the reason you don't jump every time you swallow. It's the reason your own footsteps don't scare you. It's the reason you can touch your nose with your eyes closed without flinching. Your brain already knows what's coming because your brain is the one that ordered it. The part of your brain responsible for this prediction system is called the cerebellum, a fist-sized structure at the back of your skull that handles movement, coordination, and timing. In the mid-1990s, researchers at University College London, Sarah Jane Blakemore, Daniel Wolpert, and Chris Frith, ran a series of experiments specifically to test this. They built a mechanical tickling device, a robotic arm that could tickle a person's palm either directly by the participant's own hand movement, or with a short delay, or completely independently, like another person doing it. The results were almost comically clear. When people tickled themselves in real time, they rated it as barely ticklish at all. But when there was even a small delay between their hand movement and the tickle, a fraction of a second, the ticklishness rating shot up. And when it felt completely disconnected from their own movement, it felt just as ticklish as being tickled by someone else. The conclusion? It's not self versus other. It's predictable versus unpredictable. The moment your brain loses the ability to perfectly predict the sensation, the tickle response comes roaring back. Now here's the question underneath the question. Why would evolution bother building a system like this? The leading idea is that ticklishness isn't really about tickling. It's a leftover of a much more serious survival system. Your body needs to tell the difference between touches that are safe and touches that might be dangerous. A spider walking across your neck, a blade of grass, an insect landing on your arm. These are exactly the kind of light, unpredictable touches on sensitive areas, neck, armpits, ribs, feet, that also happen to be the most ticklish spots on your body. That's not a coincidence. Ticklish zones tend to be places where a predator, parasite, or dangerous insect could do the most damage, or where you couldn't easily see an incoming threat. Your nervous system evolved to react instantly and intensely to unexpected contact in those areas, flinching, twitching, pulling away, as a rapid defense reflex. Laughter in this theory is a secondary layer. It's a social signal that developed on top of the defense reflex, which is part of why tickling almost always happens in playful social contact between people who trust each other. It's essentially a controlled test of vulnerability. If a stranger tickled you, your body wouldn't laugh. It would probably tense up and attack. Here's where it gets genuinely unexpected. That same UCL research team found something strange while running these experiments. People with schizophrenia, particularly those experiencing certain hallucination symptoms, could tickle themselves. Their prediction system doesn't cancel the sensation the same way. Some researchers believe this same broken prediction mechanism might explain why some people with schizophrenia experience their own thoughts as if they came. So is self-tickling truly, permanently impossible? Not quite. There are loopholes. If you introduce enough randomness or delay, like the delayed robotic arm in the UCL study, you can partially trick your brain. Some people report a small tickle sensation if they use a tool, like a feather, instead of their own hand, especially in a mirror, where the visual feedback doesn't quite match the timing of the sensation. There's also a documented, extremely small number of people who report being able to tickle themselves at least somewhat effectively. And researchers suspect it comes down to individual differences in how strongly their brain's prediction and cancellation system operates. It's not fully understood why, but it lines up with the general finding that ticklishness varies wildly between people to begin with. But humans aren't the only ticklish animals. Rats, of all creatures, respond to tickling in a very human way. They emit high-frequency chirps that researchers interpret as a form of laughter, and they'll actively seek out being tickled again, chasing the hand that did it. Chimpanzees and other great apes show tickle responses too, especially in social play with familiar group members. This cross-species pattern supports the idea that tickling isn't some quirky human accident. It's an old, deeply wired social and defensive behavior that predates humans entirely. Oh, back to the original question. Why can't you tickle yourself? It's not that your hand isn't sensitive enough. It's that your brain is too good at its job. Every time you move, it's already calculated the result before your nerve endings even report back, canceling out the surprise before it happens. Tickling was never really about touch. It's about unpredictability. It's your ancient danger detection system, built to protect the most vulnerable parts of your body, firing off in a totally harmless context. Which means the only way to truly tickle yourself is to stop your own brain from knowing what you're about to do. And unless you're willing to strap yourself to a delayed robotic arm, good luck with that.